In 1981, an astronomer points his telescope at a random patch of sky. Routine stuff. Mapping galaxies, logging positions, nothing exciting. Then he finds nothing. And I don't mean nothing interesting. I mean actual nothing. A region of space 330 million light-years across, and it's basically empty. Where roughly 2,000 galaxies should exist, there are almost none. His team thought the equipment was broken. They reran the data. They checked again. Triple-checked. The void was real. And here's the thing. We still can't fully explain it. 4 decades later. But what makes this even more unsettling is that the Boötes Void isn't a one-off. It's not some weird cosmic accident, because across the universe we keep finding structures that should not exist. Walls of galaxies too massive to have ever formed, voids too geometrically perfect to be random, and patterns so precise they don't look natural. Something is wrong with our model of the universe, and in this video we're going to look at the evidence. The rules. Okay, quick bit of context. Because to understand why these structures are impossible, you need to know what's actually supposed to happen. So right after the Big Bang, the universe was almost perfectly smooth. Just a hot sea of plasma with tiny, tiny ripples. Quantum fluctuations smaller than atoms. As space expanded and cooled, gravity started pulling matter toward the slightly denser spots. Over billions of years, those ripples grew into galaxies, then clusters of galaxies, and then these massive networks called filaments. And what we ended up with looks like a cosmic web. Long threads of galaxies stretching across hundreds of millions of light-years, all connected at these dense nodes with giant empty voids in between. And that web follows rules. The big one is called the cosmological principle. The idea that at large enough scales, the universe looks roughly the same everywhere. No special regions, no weird clumping. Zoom out far enough and it all averages out. There's also a hard size limit. Gravity can only work so fast. The universe is only 13.8 billion years old. So the biggest structure that should physically be able to form, well, about 1.2 billion light-years across. That's the ceiling. That's the line. So what happens when we find something 3 times bigger, 5 times, 10 times? The wall that shouldn't exist. 2013. A team of astronomers is studying gamma-ray bursts, which, just so you know, are the most violent explosions in the known universe. We're talking more energy released in seconds than the sun will put out in its entire lifetime. These researchers weren't looking for large-scale structure. They were just cataloguing where these explosions occur. Then they noticed something weird. A massive cluster of these bursts, all concentrated in one region, all at roughly the same distance from us. They do the math. They found a wall of galaxies 10 billion light-years long. It's called the Hercules Corona Borealis Great Wall, and it's roughly 8 times larger than physics says is possible. It takes up over 10% of the entire observable universe. But here's the detail that genuinely keeps cosmologists up at night. We're seeing this structure as it looked 10 billion years ago, when the universe itself was less than 4 billion years old. Gravity cannot build something that massive in that time frame. It's like finding a fully finished skyscraper in a photo from when they'd barely dug the foundation. Some researchers questioned whether this thing is even real. Maybe it's a statistical fluke in how gamma-ray bursts are distributed. But follow-up analysis confirmed it. The overdensity is real. We just have no idea how it got there. The arc with no origin. 2021. A PhD student named Alexia Lopez is doing her doctoral research, analyzing light from distant quasars, these blazing cores of ancient galaxies powered by supermassive black holes. She's not hunting for impossible structures, she's just doing her thesis work. But in the data, she spots a pattern, a curve, a massive sweeping arc of galaxies stretching 3.3 billion light-years across the sky. She called it the giant arc. Now, the size alone is a problem. 3 times the theoretical limit. Already weird, but it's the geometry that's the real issue. Arcs don't just happen randomly. In nature, curves mean something created them. Water spiraling around a drain, planets orbiting a star, light bending around a massive object. A curved structure implies a cause. But the giant arc has no visible center, no massive object pulling these galaxies into formation, no gravitational lens distorting our view. It's in effect with no apparent cause. So some physicists have brought up a genuinely wild explanation. Cosmic strings. These are hypothetical defects in space-time itself. Basically, one-dimensional cracks left over from the early universe, thinner than an atom but potentially stretching across billions of light-years. If one passed through this region, its gravitational influence could have shaped matter into exactly this kind of arc. The problem? Cosmic strings have never been directly observed. They're theoretical, a solution without proof. So, the giant arc just sits there, elegant, massive, and completely unexplained. The void that swallowed 2,000 galaxies. Back to where we started. The Boötes Void, 330 million light-years across, should contain around 2,000 galaxies based on average cosmic density. It contains 60. That's a 97% deficit. A bubble of near-total emptiness surrounded by the normal cosmic web. One astronomer put it like this: if the Milky Way had formed at the center of the Boötes Void, we wouldn't have known other galaxies existed until the 1960s. The isolation would have been that complete. Now, the standard explanation is that it started as a slightly underdense region after the Big Bang. And as the universe expanded, gravity slowly drained matter outward, compounding over billions of years into this massive empty bubble. But this explanation has problems. The Boötes Void is almost perfectly spherical. Random underdensities should produce blobs and irregular shapes, not clean geometric spheres. Something sculpted this into its current form, and we don't know what. And then there's this. At the center of the void, astronomers found a filament of galaxies running right through the middle, like a thread through an empty bead, which makes no sense. If matter drained outward, the center should be the emptiest part. Instead, there's structure there. Now here's the thing. A small number of researchers, half-jokingly, floated the idea that the void might be artificial, that some incomprehensibly advanced civilization systematically harvested the matter from this region over billions of years. It's not a serious scientific hypothesis. There's no evidence. It can't be tested, but it captures something real. The Boötes Void doesn't feel like something that was never there. It feels like something was removed, the pattern that keeps appearing. Here's where it stops feeling like a coincidence. If this was just one or two weird structures, you could wave it away. Measurement error, statistical noise, whatever. But it keeps happening. 1991, the Claus-Campusano Large Quasar Group. 73 quasars clustered across 2 billion light-years. 2013, the huge LQG, quasar cluster spanning 4 billion light-years, more than 3 times the theoretical limit. 2020, the South Pole Wall, a curtain of galaxies 1.4 billion light-years long, hidden behind the bright plane of the Milky Way that we somehow missed until last decade. The cold spot, a region of the cosmic microwave background that's measurably colder than its surroundings, possibly the imprint of a supervoid 1.8 billion light-years across. Every single one of these was found by accident. Astronomers looking for something else, stumbling into structure that shouldn't be there. This isn't bad luck. This is a pattern we can't explain. What could actually be going on? So, what are the real possibilities here? Option 1. Our models need a tweak. The Lambda CDM model, our best description of how the universe evolves, might just be missing some physics. Maybe dark matter behaves slightly differently than we assumed. Maybe dark energy varies across space. Small adjustments, bigger structures. Uncomfortable, but manageable. Option 2. The cosmological principle has limits. Maybe the universe is uniform at some scale, but that scale is way larger than we thought. And below it, genuine large-scale structure can exist that our current framework just can't account for. Option 3. Something fundamental is wrong. Not a small tweak. A deep flaw in our basic assumptions. Maybe our age estimate for the universe is off. Maybe regions beyond what we can observe are influencing what we see. Maybe the Big Bang left imprints we haven't learned to read yet. And then there are the wilder ideas, the ones physicists mention quietly. Cosmic strings threading through space-time. Phase transitions in the early universe leaving behind permanent scars. Collisions with other bubble universes in an infinite multiverse, leaving gravitational bruises on our cosmos. Or, and I want to be clear, there is zero evidence for this, structures that weren't formed, but built. The perfect sphere of the Boötes Void, the sourceless curve of the giant arc, structures that feel less like they evolved and more like they were designed. Again, no evidence. The shapes are the shapes, and the shapes are strange. Here's what we actually know. The universe contains structures that our best physics says cannot exist. Walls too vast, voids too empty, arcs with no origin point. And every new telescope, every new survey, every new PhD student going through data, they keep finding more of them. Here's what we don't know. Whether these anomalies eventually get folded into updated equations, or whether they're pointing at something genuinely revolutionary. A universe that's lumpy where it should be smooth, shaped where it should be random, structured by forces we haven't found yet. We've only mapped a fraction of the observable universe in real detail. Whatever's beyond our current reach, it's probably stranger than anything we've found so far. Cosmos doesn't owe us an explanation. It doesn't care about our models or our limits. But anomaly by anomaly, impossible structure by impossible structure, we're getting closer to the right questions. And that's usually how the big answers start. If you want to see more videos on the universe breaking its own rules, subscribe. There's a lot more where this came from.